asleep? Why do my dreams keep just out of reach? If the door will hold for me, if I don't buckle at the knees, maybe I could fool the light. Maybe I was always right. Everything the same in a different light. Try to chase the sun in the dead of night, but you were always there. I just needed time to see everything the same in a different light. A different light. Ooh, everything the same, everything the same. Ooh, if I could think before I speak, could I believe the words I preach, or will I lose my breath? Ooh, will I miss my step? If I could think before I speak, could I believe the words I preach, or would I lose my breath? Would I miss my step? Everything the same in a different light. Try to chase the sun in the dead of night, but you were always there. I just needed time to see everything the same in a different light. A different light. Everything the same, everything the same. Ooh, yeah. In a different light, in a different light.
I'd never bite, at least until you taught me to. I played nice, but still I got a war from you. Fell from grace to heaven made. Don't you forget? I've done things you can't believe. It makes your nightmares look like dreams. Yeah, you should be scared of me. Stone cold from one look in my eyes. So you wanna rule the heavens, but you're human tonight. Yeah, I'll send you to heaven when I eat you. Yeah, you're human tonight. You're only human tonight.
All right, so we're gonna get started in a second. Yeah. Oh, I need to fix the stream title. I meant to do that. We're still kind of working on ptrace stuff, but maybe not creating a ptrace wrapper exactly. We have the beginnings of that. We're mostly working on defeating anti-debugging techniques. Hopefully that'll be an interesting stream title. Maybe somebody will look at it. All right. Let me know if anybody is actually watching how this looks or sounds in the chat. But yeah, I'm gonna just get started. So where I am at is I have this program that is employing a set of anti-debugging techniques. So you can't open it up in GDB. It detects that right away and then just quits out. You cannot strace it for the same reason. And so what I started with, because both of those debugging tools use the Linux ptrace syscall and that whole system of stuff, I decided to use a pretty standard mechanism for avoiding or just mitigating that particular anti-debugging technique, which is create a ptrace wrapper and fake the return values in such a way that the program sees the values it would expect to see if it was not being debugged, but it is still actually. So you are just like interceding in its attempt to check if it's being debugged and fooling it into thinking it's not. So that was all pretty straightforward, but of course this is a more professional application. This is not just some toy program, and so they have several layers of anti-debugging techniques in place. So I'm going to switch over to, we can look at an strace output. Program loads up a whole bunch of dynamically linked libraries. It maps them. I honestly don't know if this is just what the standard loader is, dynamic loader is doing, or dynamic linker, I guess, or an strace is just showing me what LD Linux is doing, or if they are doing all of this loading on their own. I think it's probable that they're doing all the loading on their own, because I looked for the dynamic symbols with readelf for this binary. I think it's that. Oh, there's the dash. Okay. And it says it has no dynamic segment. So does this thing not depend on anything? Well, I mean, it's listed with LDD, so maybe I'm just like misunderstanding. But I thought if it had symbols that it loaded from these libraries, then we would see it under the dynamic symbol table. But it's probable that I am simply misremembering how the ELF format works. I haven't done a lot with it, so yeah. But setting that aside, it goes through all of those libraries that are in the output from LDD and maps them in, sets whatever the protections are, and maps some other stuff. I don't know, I don't care. And then it goes through and it sets read-only protection on a bunch of those libraries, but only like part of them, which is interesting. I don't know if it's like it will set execute permission on them again later, or if these portions of the mmapped address spaces are supposed to be read-only. Maybe it's like that part of the binary that was loaded in is RO data or something. Yeah, I don't know. That stuff I don't care so much about. does some stuff with a few texts and shared memory that I'm not sure about just yet, but I'm sort of ignoring that for the moment. What I'm most interested in really gets started here. We call the clone syscall to create a child thread, I guess. This is the first one. So first thing we do is we create a new thread. Pretty sure that's what the clone thread what that flag means. What are we doing? Okay, come on. Here we go. Yeah, it's in the same thread group, I guess. Sometime on this first call, we get a new PID, we get a new TID, 1819 versus 1818 for all the stuff that's been happening so far. But then if we look later, there's a call to like get PID from 1819 and it would say 1818. So my understanding is that this is in the same process, same PID, but it's just a different thread. But then when we do this clone, we clear the TID, and we definitely are getting yet another number out of the clone, so 1820. But we also, when we call get PID from that one, we get back 1820. Yeah, I thought there was another call to get PID. I guess not. Okay. Well, I don't know. Maybe they're all separate processes, separate PIDs. But the idea is the first cloned child is going to clone a grandchild, basically. The original parent thread is going to sleep for 1 full second while they do the rest of this stuff. And they're doing some stuff to, I believe, have further anti-debugging results or techniques. So one of the first things the intermediate clone, the child of the original process, does is it makes its grandchild process and then sets the grandchild as allowed to ptrace it. And then it actually ptraces its child, or the grandchild ultimately. And then it also attempts to ptrace its parent, which I guess is not what I expected. Why am I so confused? I've been looking at this for a while and I'm already still confused by what it's saying it's doing. So, okay, I see. The parent ptraces itself up here somewhere. Let's get the first call to ptrace. Okay, so no, is that really the first one? Interesting. All right. That seems incorrect from my previous experience, but I guess I'm misremembering. So 19, which is the first child created with clone, is going to attach to its own child, the second child created. Then that child is going to attach to its grandparent, which, like, I don't know why that would have worked, because it should fail depending on your Yama setting. If you're allowed to just ptrace any other process, then it'll work, but otherwise you can only trace your children, and so this is trying to trace ptrace its parent, and it didn't. 1818 didn't make this call at any point, so I don't know why this. I think the expected behavior is that it should fail. Right now, I don't have my own logging on, so even though we are running this through my wrapper, which will be returning probably 0 for this one, so it'll fake a success. It should, probably we should have it return a failure to be most accurate to ptrace. Setting that aside, what is ultimately happening is the grandchild is at some point calling waitPid to wait for any children that it has, but it hasn't created any children. And in waiting, yeah, so that returns immediately, and then it basically directly goes into killing its grandparent, which ends the whole process group. It sends the sig kill. So my guess is that something above here is supposed to have gone down a control flow path that would have resulted in the grandchild creating a great grandchild process so that the waiting can actually take place. And we don't get the -1 from saying there are no child processes to wait upon. And then because it's getting that -1, then it goes down the path of being like, okay, well, let's go ahead and kill this process group. Oh, that's what it was. Okay, so I said earlier that I thought that this first clone call was not creating a separate process. I think I was inferring that because, so that's called from 1818, and then 1819 is what spawns 1820. When 1820 calls get parent PID, it comes back 1818 rather than 1819. So my guess is that 1819 is just a different thread ID within the same process ID of 1818. Purely a guess because I don't know enough about the details of sort of Linux or, I don't know, POSIX in general, process thread spawning differences and stuff. But in any case, it seems like when they get that wait call that returns immediately and says, hey, we couldn't do that, you don't have any children, then it goes, okay, well, we're time to quit everything. Something must have gone wrong. And so I thought, well, okay, what if I, so if we look at my wrapper code, I've got a wrapper around waitPid that's being called. If you were looking closely, you might have seen that we did actually run this line of code just to say, oh, we got a call for waitPid -1. That's the last call that gets made where the grandchild process is saying wait on -1 being any of my children. And that's the one that was failing and ultimately resulting in the whole thing being killed. So I thought, well, okay, let me see if I can get into this in a debugger. I tried the trap first. That did not work. It didn't work in the same way that we'll see that sigstop also doesn't work. So, but sigstop I can actually view a little better in strace, I think. So I'm gonna just go with this bit. So recompile that, run through strace, and you see, oh shit, we get a lot of waitPid that we didn't get last time, or that you did not see in the log last time. And yeah, We didn't see all of this before. And eventually it gets around to a different way of dying. In this case, we jump into. Okay. We set this address as read and execute, and then we attempt to, I guess, write it, because we get an access error, a seg fault. So we must have been attempting to write to that address after protecting it in a way that we can't do it. So, I mean, my guess is this is just an intentional way of triggering a seg fault, which will kill the whole process group, or at least it kills. And that's coming from, yeah, that's coming from the, see, the nice thing here is I don't have anything else running on this system, so I know 48, 49, 50 means that 48 is the initial process, 49 is the first child, 50 is the last child. So that happens. Oh, yeah, okay. We talked about, we go all the way up here, and right after that first clone, the parent process sleeps for 1 second. And then all the way at the end, that sleep finishes. And it just immediately goes into this code to kill everything. So I think basically in that 1 second, the child and the grandchild and potentially other processes that get spawned or threads that get spawned from code that has not yet been executed in any of my traces will work out enough details to see that they're not being debugged, they're not being traced or anything, and prevent that seg fault from happening. That's my working theory. So all the stuff with the 2 children is what we want to look into. Okay, so in this case, we get in the grandchild, we get that weight, and we just we do a quick sig stop. I guess all of this stuff is coming from the call to raise. Yeah. And so it is stopped, and its parent, the middle entry in the process tree, is continuing to loop, waiting for its child, and it keeps getting nothing. It's got W no hang, so it's gonna finish immediately. And after some number of calls, oh no, it just does the nano sleep between each call. So it's basically in some kind of slightly busy loop, waiting on its child to finish doing whatever it's doing, at which point this other sleep finishes and kills everything. So because my immediate goal is to be able to really pause in GDB on this call to wait PID -1. We don't see the call happening here because the stop happens before we actually run the wait in our wrapper. But yeah, I want to, I guess, figure out how I can get everything stopped. So given that the thing that is actually resulting in the failure is the grandparent process, which I know from the previous log 2050 calls get PPID, get parent PID, then that should come back 2048 or whatever the original process ID is, and then we can send a kill to that process and say 6 stop, and hopefully that will prevent it from waking up, coming back from the nano sleep, and I can actually do some kind of trapping and like look at stuff in GDB. So that's the goal. So let me, I don't know, look at the kill. So we just take a PID and a signal. So let's just try that first. Throw the kill in there. Okay, so we're gonna do kill, and we do need to have signal, I guess. I don't know why. Okay, in any case, stop that. I don't know why I'm writing comments at this point. I have none of the rest of this is commented. Guess it's under 3. Yeah. Okay, so didn't actually need to import signal, but since Raise was working without it, some other header must be importing it. But just for completion's sake, we'll go ahead and do that. And recreate it, run our strace, and now it does not die. And in fact, the child doesn't either. The whole bunch of got wait PID, like, oh, okay. Just go ahead and kill 179, I guess. Yeah, so I think that my intuition about the thread ID versus process ID, or cloning to create a thread versus cloning in the way that fork kind of clones to create a new process, is accurate. I know that at the kernel level they're all just tasks or something, so that distinction is not 100% real, but I believe this is our original process ID, and then this is the grandchild, and we're missing 2080 because it's not a separate process. Why can't I kill that? Can I kill 81? No. Process state codes. T stopped by job control, and they have a lowercase t. Yeah, don't do that. Okay. Yeah. Oh, lowercase t stopped by debugger during the tracing. Okay. Interesting. Well, let's kill strace, and that should stop everything. Okay. I don't know why I couldn't just kill the child. I'm not gonna worry about it for right now. Yeah. Let me see. Oh, they're both stopped by debugger. Okay. And the TL here is multi-threaded using clone thread, like nptlp threads do. Okay. So let's run it in GDB and see if that helps at all. All right, and I've already got this in my GDB init, so it's running my wrapper. So let's just run it and see what happens. All right, so we have a stop. Look at the threads that we've got. Oh, that's annoying. Okay, because we have stopped in the parent, but I want the debugger to skip the parent stop. Just let it be stopped somehow without triggering anything from GDB, and only stop in the child. How can I achieve that? Because I'm not so interested in what's going on in the two threads that we have here, I think. Right. Creates a new thread, 2106. The frame that we're at, and the stack says that we're in nanosleep, right? And this, yeah. So I'm really bad at GDB as well, but like, in addition to having a bunch of anti-debugging stuff, the whole thing is like designed to be difficult to reverse engineer as well. So it's got no symbols. Obviously, like that's the easy thing to do, but I think it's also, I don't know, written in a way that reverse engineering tools or GDB or something is going to have trouble picking out, let's say, how to put it, picking out, what functions are where, whether they exist at all. So like, I don't know, we could attempt to disassemble some section of memory. Let's see what's at this address. Yeah, well, I mean, how do I force it to disassemble? Is it /R? No? Okay. Okay, so I don't know. Let's do +4. No. Okay. So, I mean, this address is probably going to be the address to return to in that stack frame, in that function. So it's not actually going to be the call to usleep. We'd have to go back a bit. And my guess is, call is like probably maybe 1 byte, and we've got 4 bytes for the address. That's if it's like a full, well, I mean, I don't know, the address, like this is 64-bit, so maybe it's an 8-byte call or something, but an 8-byte address for the call, I don't know enough about. We can go ahead and go to this fun website, see what we got. So yeah, we could have 64-bit memory reference. It's a displacement. know what a gate is, so I'm going to go with rip is a 64-bit offset from the var pointer referenced in the instruction. Okay, so we could be dealing with that. Could be 32-bit, could be 16. Let's start with 64 bits. So let's actually just is it quad word? I don't remember. Okay, so we had a C here, so we're going to go back 8 from C, which is probably 4. C is going to be, yeah, 12. So okay, this is the stream where we watch me be bad at GDB. Yeah. Oh, it's hot. Okay. Examine the quad word rather than print it. No. Okay. Right, what do we have for X? Oh, don't. Okay, here we go. Z. Fine. Oh, it's giant. All right. I guess that makes sense because. Okay, so what was our address for you sleep? 7F. E877. Maybe. All right, so what if we go back another? What is Rex gonna be? How long is that gonna be? You think? I don't know. 1 byte plus. I don't know how to read this opcode format. God, I'm so bad at stuff. All right, let's just try 2 bytes. And so we're gonna do a total of 10 bytes. Nope. Nope. None of that looks good to me. I mean, there is like a call at 7, but this doesn't seem like a good offset. I'm in AT&T style. I need to add that to my GDB net. Yeah, I don't know. See, this is the problem with me trying to guess at where I should go back to in the from this address, like, because x86 has whatever the fuck instruction lengths. Okay, so I mean, one thing we can do, right, is go back far enough that we get an instruction that maintains, like, this is almost certainly the correct instruction at that. In fact, we were looking for, I guess, the result, something being put into EBX is going to be, what, 13? From our call to uSleep? Does that seem right? Wonder if guess it's just part of POSIX. So yeah, why does it want 0D in EBX? I don't know. But this bit seems correct. Okay, so, and interestingly, that call does. Alright, what if we run this and like put a breakpoint at this address? How do I do that? I thought I just had to. Let's like put this star in front of it, right? Okay. So we're gonna break at that address if we run it again. Okay. So this is step one. No. Why is this our address? Okay, so we're at E9DBB7. Yeah, what the fuck? So like, I don't know, that is that normal that the first stack frame is at address 0? I mean, maybe they're doing something weird like clearing out the writing something to the values above them in the stack so as to clear it out and cut off any information that might be used to determine further down the stack. So we're breaking at this address, which is the call instruction, and we hit that address, but why did step I? So we were in thread 2, and then we tried to step, and then we switched over to thread 1. Yes. Okay. So thread 2 is what actually hit that point. Does that help? Okay. Can we switch to one of these threads? Just thread 1. Okay. All right. So if we step this one, does that help at all? Or are we just stuck with the thread 1 getting the stop? No, okay. Yeah, so we're not moving ahead at all. let's look at table of contents for the GDB. Look for signals. All right. So let's look at the signals, look at the handles. So many signals. Let's look at handle. Look at sig stop. Okay. We want to not stop, but we will pass maybe. Okay. So we'll handle sig stop with stop. And let's run it again. Do I kind of do file again? I guess because it has switched threads. So what happened? Yeah, then we get that same fault. Because it did not stop the process now. Oof. Even though we have that breakpoint. We hit that breakpoint 35,000 times? 3,500 times? What? Oh, I just feel so bad at all of this, really. So, what I want to do. I really want to, like, keep thread 1 stopped, but let thread 2 happen. Or, I mean, honestly, let's look at that. Okay. Fun. Sorry for the white screen. Okay. I guess we can try scheduler locking. Let's replay. Okay. Got. Oh, this is old GNU. Oh, maybe I should be using this stock. And on and replaying. Oh, okay, that makes sense. If we were replaying something. Is it with just set? Okay. Set the file again. Yeah, there's not going to be any debugging symbols. What? I just said it. Just do the thing. Alright. So thread 2 hit the breakpoint. Yep, okay. So and then it receives 6 top. But it did call that, so that was the accurate bit of code. Is it not? Let's say, okay. There we go. That has probably tripped me up before, just too much jump queue. None of this seems, oh, this is right. So this is like, we've jumped into the global offset table or whatever. Now we are, why did we not jump? Weird. Okay. Oh, you know what? It's probably, right, let's say I print some number of instructions. Maybe it's in the examine. Yeah. So okay, right. It's coming back to me a little bit. So we can print 20 instructions from the instruction pointer. I really need to install something like GDB PETA or one of the other hacking add-ons. So we're going to push that, and we're going to jump to that address, but I don't, okay, I don't get why this jump didn't happen. Yeah, see, okay. Alright. Interesting. Okay. So can at least access. I forget what. It's gonna be a PDF. I don't want that. Ugh, visual GDB. Just print me. I don't want list where I'm at? Okay. I guess it doesn't have the source code, it said, right? So, okay, let's let that slide. I'm just gonna, like, I don't know how much I need to do before we get to the next function. Okay, so that is the call to uSleep. Has to go through the trampoline first. I probably could have seen this on in the strace output if we go back far enough, but I'm not going to do that. So all of the code is going through this this code path called uSleep, which then I guess does the nanosleep syscall. I decided to tempt fate and like open up or switch to OBS to see my mic levels, because I've been talking a bit further away from the mic in the last couple minutes at least, and it crashed because I decided to look at it, because that's just the reality of OBS on Wayland with Qt on Wayland. It don't work so great, and there'll probably be a stream in the future where I spend some amount of time trying to debug it and then fail, but you know, that's life. Okay, so I've switched away and I'm not going to click on OBS, and I'm just going to hope that the fact that it started up again with my microphone muted is because that was the last saved state that it had, and not because my microphone has been muted for the past hour and I've just been talking to myself and making a very uninteresting stream. But on the off chance that my microphone was muted this entire time and somebody was looking at this for some reason, hello. Yeah, okay, so we're still attempting to debug this program, or I don't know, not debug the program, but reverse engineer the program. All right, so I have the breakpoint for the call to uSleep. That is not interesting to me. What I want is the code that calls kill. Yeah. All right, so I guess I need to make a wrapper for kill. Well, that's an interesting idea. Okay, so rather than go into making the wrapper for kill, thinking, what if I take out the stop that is killing the parent process, the one that we added earlier in the stream, and we just raise stop on that grandchild process. That should if we are running in scheduler locking on, then that stop should trigger in GDB, and the other threads will not execute, so thread 1 won't wake up and go through its segfault logic, meaning we can debug from the code in the call to wait PID that when it fails results in that thread killing the whole process group. All right, so let's try that instead. So we'll just not do that. Rebuild and go to GDB. Let's make sure to do Intel syntax because I much prefer that. And I never remember what the friggin' command is. Right. So we can start this up and set scheduler locking on. Okay. I guess we need to run it like it doesn't know what, because we haven't actually attached to anything, so it doesn't know what our platform is, so it won't set it to on. And it's going to want the file again. And that did not help. Great. So the fact that we call sig stop, right? Like we raise sig stop. Why don't we try kill? I don't see why this would be any different, but I don't know what the hell I'm doing. So we'll run it. It'll do its thing. It didn't stop. Oh, you know what? It's okay because that's a child process. I really should have. Who knows how long I have spent doing the wrong thing in GDB because I have yet to set on follow child processes. Set follow fork mode child. Okay. I'm gonna put that in here. Set. No, because it doesn't work until you run it. And does not help. Oh. Or it does. It doesn't stop at this point. I'm not a fan of whatever's going on here. Oh, they got me. They got me. Wow, okay. No? Okay, it just needed to. Oh, what a delightful situation I've got myself into. So, alright, I'm gonna go ahead and not log that information, although that's not the ultimate problem. Let's see, what are we gonna do? So when we follow the child, it means, well, okay. At least this time. Okay. I don't know what the heck. Oh, I guess it is because I wonder if I can still stop the parent now. So I think we were actually getting this info and the prompt to do stuff, but because my wrapper code was just shitting out info about the fact that the other process was doing this infinite loop of calling wait PID, we weren't able to see that, and it didn't help anything. So probably if I hit Control D or something, I would have quit out of GDB. Alright, let's try it. Syscall template.s. Where are we? We are in kill. Why are we in? Oh, right, okay. Now, let's see if we can use the cheat sheet to walk up the stack, because I never remember what I'm doing. Up. Yeah. Towards main. Alright. And okay. So we call wait PID. -1. If it comes back as -1, then we jump to upwards somewhere. Jump back. Okay. Let's do. Ooh, we jump back quite a ways. Hmm. 1500? Does that help at all? Okay. Does that seem like, and a lot of this seems questionable. I mean, maybe not. I guess it's not, because we're doing a call and then we're checking if it's -1. Like, that seems accurate, actually. So we're jumping. We jump to this address, which then sets up stuff. I don't know. Oh, I guess we could just do like 9038. Why do we just move a bunch of data into pointers? Oh, this might be real deal code to do like interesting stuff. Otherwise, so this is the thing that we were looking at a while back, I think. That comparison of EBX to, what is that, 13? No, 12. No, 11. I know what I'm doing. I know how to count. Don't tell me I don't know how to count. Okay, so yeah, we compare EBX against 11. I don't know what EBX is going to be in this context. But I would say that's the sort of pathway that we go down to cause. Oh, Let me jump. He's so far away. Yeah, I don't know. Just even more not stuff of just pushing stuff on the stack, I guess. Not actually pushing, but moving stuff off of the stack onto the. Ugh. Why am I letting myself get messed up? I'm so much worse at this on stream. Believe me, everybody watching. This I'm so much better at this when it's not being recorded. I'm practically a master at it. All right, so let's just try and not return -1. So we were passing no, like W no hang up or whatever, no hang. So returning immediately should be fine. And yeah, if we return something that's not equal to -1, let's see what that does for us. All right, hopefully making some progress. Hopefully. Take out all of our stuff for now. We'll just return 0. We'll just say, fuck it. Everything was groovy. Right. It's really gonna be that. Okay. Return value. On success, returns the process ID of the child whose state. If W no hang was specified and one or more children specified by PID exist but have not yet changed state, then 0 is returned. Okay, so that's what we intend to act like happened. And you know what? Let's give it the old strace first. Alright. So we hit the time limit, I guess. Let's call it that. Grand Peppy woke up and said, I was shutting this bullshit down. So, and then it goes into like, let's open the process. Let's open the process status and kill. And then exit. So its wait ends. Right, so this is all the waiting that we were doing in a loop in the middle process. It does come back because this one eventually decided to quit itself. I do find that attempt to kill the process group, it's just so confusing because earlier this one is like calling to move, so it attempts to kill its parent, in this case 72. Oh no, that's it does, okay, so it attempts to kill the process group for 2372, which is interesting. That do we not yeah, I don't know why that kill doesn't do anything, but I also don't know that I care. So then the middle process finishes waiting for its child, and then attempts to wait on it again, which, yeah, I don't know, I don't get. And then I don't actually know what these shared memory functions are about. Schmidit function operates on XSI shared memory. We can get the. Alright, I much prefer the Linux ones for some reason, the Linux man pages. Schmat attaches and Schmidat detaches. So it's Schmidit. Okay. And then we schmickatel in the vein of ioctal, schmachtel, to get the status of, I don't know, let's find out what that is about. The Schmid. All right. So then this one is just the, that should just be the address, right? The schmatter. So you call schmidit with the schmatter, and then schmachtel with the schmid. This is probably triggering somebody to say, keep saying that stuff. So, all right, so we do the shared memory control stat, get the infos. Yeah, I don't know. I feel like what really worries me is that there's probably yet another layer beyond all of this where these various other processes and threads will be communicating via shared memory in a way that must work exactly. Like, I need to ensure that the exact right code paths are being followed so that the information being put into these shared memory maps, or whatever you want to call them, address spaces, is correct, and it's going to do stuff like check the values that are put in there. But maybe I'm just being self-negative. I just don't know for what other purpose it's opening such things. All right, so all of this is happening in that middle till we've got the few texts going. And all right, so, and then we still get killed by the parent. So, like, let's just still send the stop to it. I just not. No. All right. So send stop. grandparent. Cool. And it is also stopped. God damn. Okay. Well, that's interesting because it opens up. Oh, right. Okay. Then it exits. Ba-da-da-da-da. What do I want to do now? I have no idea what it is doing, why it is doing it. Sorry for hitting the table, and you can probably hear that decently on the microphone. Of course, I have no idea if you can hear it on the microphone because I am not going to switch back to the OBS window and have it crash on me again. Not until I choose to end the stream. Yeah. I wonder if there's like a kernel mode trace. Not for tracing the kernel, but to be able to get this output about the specific process without there being any ptrace information. I think it's like actually setting that up would be so much more work than whatever I'm doing right now. What is utrace? All right. Okay. Utrace might be interesting. I have to just write all of this stuff myself. Oh, let me run some music for myself. I think I have it set up so that y'all can't hear it. Because, you know, enjoy your own music. Maybe you don't want to enjoy some trap music or whatever I'm listening to. And also, I don't want to have my video muted. The previous one was muted, but I wasn't talking on it at all, so I don't care too much about that. But in this one, you know, obviously everybody needs to hear my very important thoughts as I browse through an article that I should be reading in full. And so, can't deprive the people of that kind of thing. Yeah, so we can get reports of any syscalls that happen. We can attach see if we can do like a utrace based strace. See if anybody has written a nice front end tool. And I don't have to write the C code for this kind of thing on my own because there's just so many syscalls. I don't want to do that. Is the utrace project dead? Oh no. Oh. Alright, well, and that was from a solid 8 years ago. Okay. I feel like asking for something like this for my very weird circumstance of trying to debug a program that does not want to be debugged is not going to get me a lot of particular help from folks. I get it. Why don't I just debug my own software, you know? It's got bugs in it. Needs a thorough debugging. Yeah. Alright. What do I want to do? How should this work? I want to see. Okay, let's have it print out the call stacks. Strace can do that. So at least I can see, like, when did we get to calling, kill, and exit, and all that. I don't remember. Let's go backtrace. It's called call stack. With the execution stack trees. Okay. So when we got to our read, we're here. Ooh. Oh, I should turn off ASLR, because this is not helping me. What is it? It's like randomize. I just need to. Why do I echo 2 at it? Oh, let's see. Conservative. Interesting. Oh. Okay. I don't know enough about break to know why it would need to be special cased. Does that work? Should be fine, right? So let's let's see, what are these addresses we're getting? I got like a, should have a wait. Okay, so got wait pid called from this address. And then we're calling open at from here in 2525. Kill. Oh, that's my own kill, I guess. Right. Yeah. Okay. Then E18C. These are different addresses from. Run it again and see if I get different addresses somehow. No, same addresses. Or, yeah, I think that's the same addresses. It's just they were at something else. I guess these are the offsets from where a text section of game is loaded. Okay, maybe I can do that. So look it over there, and we will run it. Is anything useful? It's not going to stop, huh? Why don't I put in like a sick trap? I need to stop the parent. Yeah, still need to do that. Okay, so have that loaded up. Oh. Well, let's see if we can just still do it in GB. Okay. So I'm going to finish that. We are here. Okay. In my codes, do we have actual like source line debugging? Yay. Alright, so next out of that, come back, and now we are at back in the shit. Ugh, okay, I've lost the plot on where things were at, though. I guess that's go get pit. Yeah, okay. So he didn't ever end up calling. Alright. So then, in theory, I want to see what we got going on now. So much nonsense. Just so much nonsense. Is it 20 bytes or something? Like, it's basically almost all empty. We'll step high, like let's step through all of that. And a few of these bits have stuff in them now. If we do like you can see various little things in there. Okay. This is the kind of shit that makes me feel like I am honestly just very slowly wading into the actual challenge. Oh, what the fuck is it doing? Just can't even, man. It's gonna do this nonsense, and then it's gonna compare. It's -1. Alright, well. Where are we at? Okay. Wait, what? What the fuck? Did we jumped somewhere, huh? God damn it. We probably jumped somewhere and then jumped somewhere else. Oh. I just don't, you know, I just feel like I'm so out of my depth. Let's see what happens if we step forward another 20. Where are we at? Somewhere else entirely. Some point we're gonna call a thing. Is this the trampoline? Alright, so that's, we're not gonna jump anywhere before we get to the call. So step forward. have to call, correct? No. Push that address. Well, we jump, then we push. Right, yeah. Yeah, now we're in sprintf. Okay. So we did a bunch of nonsense. And got ourselves. Yeah, I feel like whatever the fuck was happening in all of this, and wherever else we went between here, like this jump and however we got here, you know, is doing some real work to decide if where we're gonna get to. I have no idea how we ended up where we're at. And it's gonna just be so tedious to trace through all of this. It's one of these, like, maybe I could try to run this with Kira. Run it in QEMU. How do I, you know, it's gonna probably try to load a bunch of resources. I mean, it needs to load the dynamically linked libraries, at least. Didn't seem like it was reading. I mean, it read from proc. It opened up the shared memory files, but it didn't necessarily have a bunch of other stuff that it was doing, like accessing external data. So if I can figure out how to make sure that QEMU, you know, gives it the library files that it needs, these ELF files and all of that, then maybe I could get a Kira trace out of it. I'm not very good at Kira, but I just want to get to this chunk, you know? Oh, maybe I could core dump and then like in theory should be possible to, well, I, you know, like, okay, in theory maybe you could make a whole core dump at, you know, at the point that we return back, and then have GDB keep going from there. I don't know. We wouldn't have the right kernel resources, file descriptors, and whatnot, so it's, even if it would work in this case, it's probably not something that's supported because there's so many cases where it would be a bad idea to try to continue execution from a core dump. And in this case, it's probably not as helpful as it would seem, because my strong feeling is that it is very likely that whatever the fuck is going on with, you know, what nonsense we're writing into here, if this is part of the anti-debugging and you know, just like making something very difficult to reverse and all that, it is probably something that involves the other threads and processes in order to work correctly. And so really we want a trace that follows both threads from the parent process and then the child process that is created, and gets the full trace log of all three of those threads, so that we can and does so for the version that runs successfully when it passes all of its checks for debugging stuff, because we're actually just running it in QEMU, which shouldn't trigger any sort of debugging related checks like what I'm dealing with right now. So yeah, I don't know. I mean, I feel like I've made a little tiny bit of progress in understanding what it's doing, but there's quite a bit more to be done, and I think I want to shift my focus towards maybe I can run this in Kira and get a trace, and then we can work through, oh, this code tries to calculate a value based on all of these data points, all these bytes in memory, who put those bytes there, that sort of thing. Yeah, I mean, the reality of this is that professional people are working to stop me from doing exactly what I'm trying to do right now, and I'm not that experienced, so the odds are not in my favor on this one. Yeah. Let's see if I go back into OBS and put up that AFK scene that I created. It's just such a high chance that clicking onto that tab is going to crash it. So, with some degree of caution or whatever, I'm just going to say straight off, if this crashes OBS, I mean, I'm basically done with the stream anyways, I think. So if this crashes OBS, then adios. Thank you for watching. I mean, I see one viewer, but I think that's probably just me in the stream manager or something. If there is one person watching, nobody said anything in chat, so I don't think anybody is. But if you are there watching, thank you for watching. If you're seeing this on a recording, thank you for seeing the recording. Yeah, and click